Hello all, I am Neha Prajapati, Assistant Professor from Computer Engineering Department, Ahmedabad Institute of Technology. Today, in this third video lecture, I am going to discuss about the third page replacement algorithm least recently used. Welcome back again for the third page replacement algorithm that also known as a LRU. This recently used algorithm is very different than FIFO and OPT algorithm. There is a key distinction between the FIFO and OPT that in the means of other than looking forward and backward. Because in the FIFO algorithm that uses the time when a page was brought into memory, whereas in the optimal page replacement algorithm that uses the time when a page is to be used. These two scenarios in the manner of a future and the backward. So if we use the recent past as an approximation of the near future, then we can replace the page that has not been used for the longest period of time. This approach is the least recently used algorithm. Means that we have to check which page is least used in the backward manner. So is uh, this algorithm is used in the time manner for the pages that is in the last use. So when a page must be replaced, the LRU chooses the page that has not been used for the longest period of time. So we can think of this strategy as OPT is looking forward in the time rather than in the forward. So let's explain this example and understand this example by using a four frames. The LRU, we solve this example by using four frames as well as for the three frames. So considering this reference string, here the reference string is page 1, page 2, page 3, page 4, page 1 up to a page 5. Here the buffer size means the frame size is 4. Initially this buffer is a blank. Frame 1, frame 2, frame 3 and frame 4. So first what we have to check, we have to find the number of page fault and number of page hit. So we have to check if the page is request for the buffer is available in the memory or not. If the page is available in the memory, then that called as a page hit. But if page is not available in this memory, then it's known as a page fault. So when the page is not available in the memory, the page fault count is increased by 1, and when the page is available in the memory, at that time the page hit count increased by 1. So let's start this example. So initially page 1 is request for the buffer. At that time the frame 1, frame 2, frame 3, frame 4 are initially blank. So 1 is not there. Then it is a page fault. So page fault count increased by 1 and we put this 1 into the frame number 1. Now page 2 request for the buffer. Here we can see that frame 2, frame 3 and frame 4 are blank and we cannot find 2 in these frames. So here page fault is increased by 1 and we put this page 2 into a frame 2. Now check for the 3. Here again frame 3 and frame 4 are blank and we cannot find page 3 in these 4 frames. Then again the page fault count here is increased by 1 and we put the page 3 in the frame number 3. Now page 4 is request for the buffer. Again we cannot find page 4 here. So we put the page number 4 in the frame number 4 and again the page fault count is increased by 1. Now let us check for the page number 1. Now buffer is full and now we have to apply the rules for the LRU page replacement algorithm. We have to check in the backward manner. So 1 is replaced by which page? But first let's check 1 is available in the memory or not. So first we check 1 is available in this memory. So yes, here 1 is available, means that 1 is present in the table, so it is a page hit. So here page count for the page heat is increased by 1. Now check for the page 2. So again check page 2 is available in the memory or not. Yes, here it is. So page heat count is also increased by 1. Now we check for the page number 5. We check page 5 is available in the memory or not. So here page 5 is not available and we have to replace one of the page from this buffer by a 5. So which page is replaced? So for that we consider the rules for of a LRU algorithm, and we increase the page fold count by a 1. So now which page is increased? So we have to check in the backward manner which page is least recently used. Means that for the 5 we check in the backward manner. Here 1 is used recently, 2 is used recently, 3 is used here and 4 is used here. Means in the backward manner which page is used last. Means here we have to consider the timing, which page is used least and last. So here from 1, 2, 3 and 4, 3 is used in the last in the backward manner. So we have to replace the page number 5 by a page number 3. So here we replace page number 5 by page number 3. Sorry, in the page 3 is replaced by the page number 5. So now we check for the next page. Here the request for the page is page 1. So we first check in the memory if 1 is available in the memory or not. So 1 is here, means it is a page heat. So again page heat count is increased by 1. Now we check for the page number 2. First we will check in the memory if the page is available or not. So here again 2 is available in the memory, then again the page heat count is increased by 1. Now we check for the page number 3. So page 3 is not available in the buffer in the frames, then we have to replace one of the page by a page 3. So which page is used? So let us check in the backward manner. So in the backward manner if we check, so 1, 2, 5 and 4. So here 1 is here, 2 is here, 5 is here and 4 is the last used. Means from 4, 5 and 1, 2 we use the 4 last. So we have to replace page number 4 by a page number 3. So here we replace page number 4 by page number 3 and we increase the page fault count by a 1. Now we check for the page number 4. So first we check in the memory, so in the buffer, if page number 4 is available or not. So here page number 4 is not available. So we have to replace one of the page from that and increase the page fault count is plus 1. So here page number 4 we use the buffer 1, 2, 5 and 3. So here you can see that 1, 2 is here, 3 is here and 5 is the last used page. So we replace the page number 4 by the page number 5. So here now value is a 1, 2, 4 and 5 and that increase the page fault count by 1. Now for the last we use the page number 5. So for the page number 5 we check the buffer. Here 5 is not available, means that page fault count increased by 1 and we have to replace one of them value, one of the page from the frames by page number 5. So here 1 from 1, 2, 4 and 3. 1, 2, 4 and 3. The 1 is used last in the backward manner. So we replace the page number 5 by a page number 1. So in this least recently used example, we see in the backward manner that page which used last and that page we replace by a new page. So here you can see that for this reference string, number of page fault is equal to 8 and number of page heat is equal to 1, 2, 3 and 4. So total number of page fault is equal to 8 and page heat is equal to 4. So now let's take a second example. Reference string for this LRU algorithm is 12341251234 in this example by using the three frames, and here the total number of page faults is equal to 8. So let's start. Here it's page 1. Firstly, in the buffer is not available, then page fault one count 1 and we place 1 here in the frame number 1. Now second is placed in the frame number 2 because initially it is not available in the memory, and it increase the page fault count by 1. Page 3 is request for the buffer, and page 3 will not find in the buffer, so page 3 put in the frame number 3, and that also the count increase the count of a page fault by 1. Now check for the 2. 2 is available in the memory. Yes, here 2 is available. So if 2 is present in the table, so it is a page heat. Now we check for the 1. So here 1 is also available in the memory. So again page heat count increased by 1. Now check for the 5. So 5, for the 5, first we check in the memory is available or not. So here it is not available. So we have to replace 5 by one of the page. So which page we have to choose for the replacement? So that is we use for in the backward manner. Which page is used last? So from 1, 2 and 3. Here we can see that from 1 to 3, 3 is used the last. So we have to replace that page by a page number 5. So continuously in this manner you can solve this example, and in the last you can see that there are number of page faults and page heat count is increase and increase, and in the last you can see that your answer is here. So here number of page fault count is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the page hit count is 1, 2, 3, 4, 5, 6, 7 and 8. The total number of page fault is 11 and page hit count is 8. Okay, so now you have to solve this example by your own. Here is a reference string for the pages 1, 2, 3, 2, 1, 5, 2, 1, 6, 2, 5, 6, 3, 1, 3, 6, 1, 2, 4, 3, and you have to solve this example by using the three strings, and here total page fault count is equal to 11, but also you have to find the page heat count. So now LRU page replacement algorithm you can consider as an advantage because it is used for the normal program behavior. The programs are written to contain loops which cause the main line of the code to execute repeatedly with special case code and rarely being executed. This set of pages that contain the code that is executed repeatedly is called the code locality of the process. An LRU replacement algorithm is explicitly designed to take advantage of locality by assuming that if a page has been referenced recently, it is likely to be referenced again soon. So here we can see that the comparison of the optimal page replacement algorithm with LLRU. Here is an example of a process of 5 pages with an operating system that fits the resident set size to a 3. Means here the frame size is equal to 3 for both algorithms OPT and LRU, and for this is a string, reference string. So here we can see that in the optimal page replacement algorithm there is a only 3 page fault, and as compared to that in the LRU we can see that there is a 4 page replacement, 4 page faults. So now here again the comparison between the FIFO and LRU, we can see that in the LRU for the same string there are 4 page faults, and in the FIFO that is a 3, 4, 5 and 6. So comparison between the OPT, LRU and FIFO, we can say that FIFO is not feasible, and It is a advantages in the manner of the implementation because it's simple to implement. But optimal page replacement algorithm is the best algorithm from three: LRU, FIFO, and optimal page replacement. LRU, we can say that it is an intermediate because that is maximum approximation up to a OPT, but it is not a OPT. So that is an approximation, but LRU we can consider in the second manner, and that LRU is as advantageous that it recognizes the pages 2 and 5 are referenced more frequently than others, but FIFO does not. So FIFO cannot identify which page is recognized in the manner of more frequently, but LRU can recognize that. So here the implementation of the LRU policy means LRU list recently used is used the stack for the implementation because each page could be tagged in the page table entry with the time at each memory reference, and the LRU page is the one of the smallest time value that needs to be searched at the each page fault, and very few computer systems provide sufficient hardware support for a true LRU replacement policy. So the LRU algorithm that used by implementation of a stack implementation. So here is the LRU implementation that used in the counter implementation. Means that every page entry has a counter. Every time a page is referred through this entry and copy the clock into a counter. And when a page needs to be changed, that look at the counters to determine which are to be changed. And this algorithm is implemented for the page reference. So stack is used in the manner which page is used in the last. So in the stack, which page is in the bottom one? According to that, the stack can be a track of pages that which used in the last. So list recently used algorithm is easy, but that is also hard to implement because we are using the stack implementation compared to a FIFO. So FIFO is very simple compared to that. LRU is not that much easy. Thank you.